convolution theorem. Before going to convolution theorem, we have one definition. Convolution product. Definition: suppose f of t and g of t be two functions defined for t is greater than 0. Defined for t is greater than 0, we define f of t star g of t equals to integral 0 to t f of u g of t minus u into du. This f of t star g of t, this star is called convolution product. This convolution product of two functions f of t star g of t is nothing but convolution product of two functions f of t and g of t. Now one important property, f of t star f g of t equal to g of t star f of t, means convolution product of f of t g of t equals to convolution product of g of t and f of t, means this is nothing but commutative property, means both sides are also equal. This is convolution product. Once you know the definition of the convolution product, by using this one we can apply convolution theorem for the problems. The topic is convolution theorem. Suppose Laplace transform of f of t equal to f bar of s and Laplace transform of g of t equal to g bar of s. These both are known things. Then Laplace transform of f of t star g of t, means convolution product, equal to f bar of s into g bar of s. This is convolution theorem. Laplace transform of f of t star g of t equal to f bar of s into g bar of s, or L inverse of f bar of s into g bar of s equal to f of t star g of t. Then this convolution product is useful. Convolution theorem is useful. The product of two functions are available. If you want to calculate the inverse Laplace transform of two functions, means those two functions are in multiplication, then this theorem is very useful. Very easily we can calculate the answer in terms of t. For that purpose only, means before that one, Laplace transform of f of t and Laplace transform of g of t, if these both are known things, then we can apply this theorem very easily by using convolution product. Let me solve some problems on convolution theorem. First problem, using convolution theorem, find L inverse of 1 by s plus a into s plus b. This is first problem. Second problem, L inverse of 1 by s into s square plus 4. Now observe this one. Here we have two functions in the first problem. Now I will solve the first problem here. First one, f bar of s equal to 1 by s plus a and g bar of s equal to 1 by s plus b. Now what I am doing here in that question, L inverse of product of these two functions. Previously we have used the same problem by using partial fractions, means without using partial fractions we are calculating this, inverse Laplace transform of this function. Now f of t equal to, what is f of t? F of t is nothing but L inverse of f bar of s. L inverse of f bar of s is 1 by s plus a, that answer is e power minus at, means finally f of t is nothing but e power minus at. Now g of t equal to L inverse of g bar of s, that equal to L inverse of 1 by s plus b. The answer is e power minus bt according to basic formulas. Now I got f of t and g of t. By convolution theorem, L inverse of 1 by s plus a into 1 by s plus b, means that can be written as, I am writing very clearly, L inverse of 1 by s plus a first function into 1 by s plus b, that can be written as L inverse of f bar of s into g bar of s. Now from that theorem statement, the answer is, what is that? L inverse of f bar of s into g bar of s is f of t star g of t. That is according to convolution theorem. Now Actually, I am writing here f of t star g of t equal to integral 0 to t f of u g of t minus u du. Now, but f of t is e power minus at, means f of u means I'm substituting every function here. You know very well f of t and g of t. Just in place of t, you substitute u. In g of t, in place of t, you substitute t minus u. Now I am doing that concept. Integral 0 to t, f of u means e power minus au, because f of t is e power minus at. E power minus b t minus u into du. Then observe this one, e power minus bt is constant, integral 0 to t, e power minus of a minus b into u. Now bases are same, add the powers according to that concept we are calculating here. E power minus bt is, it is free from u because we are doing integration with respect to u. Now you do the integration, e power minus bt is outside, e power minus of a minus b u by the coefficient of u is minus of a minus b, right? Now you take the constant outside and apply the limits. Upper limit is t and lower limit is 0. Minus of 1 by a minus b into e power minus bt. This total part is constant. Now I am applying t, e power minus of a minus b into t. When you are substituting lower limit, it becomes 0. Now that is minus 1. Now b minus a, I am taking minus common, it becomes minus into minus plus 1 by b minus a e power minus at minus e power minus bt. This is the final answer for this one. Like this we can calculate it. Now second problem, L inverse of 1 by s into s square plus 4, means the first function is f bar of s is 1 by s and g bar of s is 1 by s square plus 4. Now first you calculate f of t and g of t. F of t equal to L inverse of 1 by s. L inverse of 1 by s is 1 and g of t equal to L inverse of g bar of s, actually that is 1 by s square plus 2 square. That 4 can be written as 2 square. From the basic definition, 1 by 2 into sine 2t. Now I will apply the convolution theorem. L inverse of 1 by s into s square plus 4, that is nothing but L inverse of, clearly the first function is 1 by s into 1 by s square plus 4, that is nothing but L inverse of f bar of s into g bar of s. Then this is nothing but L inverse of f bar of s into g bar of s is nothing but f of t star g of t. This is by convolution theorem. Now that I am writing here f of t and g star g of t, that is nothing but convolution product. Just I am writing here definition of the convolution product. Integral 0 to t f of u g of t minus u du, that equal to integral 0 to t 1. F of u means f of t value is 1, that's why f of u value is also 1. The same constant function. 1 by 2 into sine of 2 t minus u, replace t by t minus u because g of t minus u is available, into du. Then 1 by 2 is constant outside, integral 0 to t sine 2 t minus u du. Then after calculating, applying integration, 1 by 2 is outside, integration of sine is minus cos 2 of t minus u by minus 2, because the coefficient of u is minus 2, that's why I wrote here minus 2. The limits are, upper limit is t and lower limit is 0. Then at last 1 by 4, that equal to 1 by 4 cos 0 minus cos 2t. Just I am applying limits. 1 by 4 is outside, I have taken minus cancel, 1 by 4 is outside. The upper limit is cos t minus t, cos 0. Then again u place of in place of u is 0, then it becomes cos 2t. Therefore the final answer is 1 by 4 into 1 minus cos 2t. Like this we can apply convolution theorem.